I am now recording. Let's get started. For our first homework assignment in part 1, you were to play this game here, Penji's Binary Blitz. Take a screenshot, post your video there. But what we're really here for is to work on part 2 together. So the first question asks us to convert this number in binary to the requested format in decimal. My first step is I'm going to rewrite all of these, 0, 1, 0, 0, nice and spaced out. That way, when I underline them, I have room to write their place values. So this is the 1's place, the 2's place, the 4's place, 8, 16, 32, 64, and 128. You should have these memorized eventually, but really what we're doing here is we have a base 2 numbering system. So we have 2 to the power of 0, which is 1, 2 to the power of 1, which is 2, 2 squared, which is 4, 2 cubed, which is 8, 2 times itself 4 times is 16, and so on, which is really how we get our decimal system, which is a base 10, because we have 10 to the 1, 10 to the 0, 10 to the 1, and then 10 squared, which is how we get our 1s, our 10s, and our 100s place. So that's just a recap of where these numbers are coming from. So I'm not just making them up, they're really coming from base 2 with different exponents. But for the purposes of our lesson, you can just ignore that. And remember, we have 1, 2, 4, 8, 16, and 32, 64, 128. So to get our decimal, we know we have a 1 in the 64's place. We can ignore the 32, we can ignore the 16. We're going to add a 1 in the 8's place. We're also going to add a 2, and we're going to add a 1. Combining this together, well, that gives me 10. So 64 plus 10 is 74. Plus 1 gives me 75. And that's how I'll do the first problem. So going from binary to decimal is pretty straightforward. You just label the place values and then add up everything that has a 1 in it. The more challenging exercise is going backwards. So notice in this case, I'm given a decimal and I want to go backwards to binary. I want to turn it into 1s and 0s. So we'll start with the same process. We will lay out a few of these. Since the number I need to represent is 42, I don't need to go all the way to 128, right? 128 is way too big. I also don't need to worry about 64 because that's also too big. It doesn't even fit in 32. Both of those guys would get 0s. So I don't need all of the place values. But I definitely don't need a 1's place, a 2's, a 4's, an 8, a 16. And do we need a 32's place? We do, because that's the largest number that fits inside 32. So remember, the rule here is step 1, put a 1 in the placeholder or the place value. Let me use some specific language. Put a 1 in the place value for the largest number that fits without going over. That fits inside your decimal value, in this case, 42. So we're going to put a 1 in the 32 place for sure. So far, if I were to add this up, if I put 0s everywhere else, my number is 32. But I want 42, not 32. So I still have to go how much further? Well, 42 minus 32 leaves me with 10. And that's our second step, actually. So subtract that place value to see how much further to go. So right now I know I need to go 10 more. So now I'm going to repeat. I'm going to go back to step 1, but now with my new number 10. Well, the biggest number that fits inside 10 is 8. And we do that again. Well, now how much further do I need to go? I just need subtracting 8 from 10. I see I need 2 more. Ooh, there's a 2's place. Perfect. So in our last step, we're just going to put zeros everywhere else. We did not need a 16, a 4, or a 1. And so our answer is 101010. I'm pausing. Any questions so far?
Wait, Miss, I think I got something different when I did it.
Tell me about it.
Wait, hold up. Wait. Oh, no, never mind. I got the same one, but I just put the 2 zeros in front.
There were 2 more zeros. Yeah, and that's a good thing to bring up. That's the same thing as if I had said 0, 0, 1, 0, 1, 0, 1, 0. In fact, I could add as many zeros on the left as I want because I'm not using any of those values. Thanks for bringing that up. Okay.
Number 2, yeah.
Okay, perfect. That's what we're going to do. So let's go to number 2. We need to put these numbers in order from least to greatest. Now, this is like an actual AP question, which is why you're seeing it's kind of a wacky looking question, but it's come up on the AP exam. So the first number is in binary 111. Note, this is not the number 111. Okay, it's not 111. This is binary. So as before, we'll give them place values of 1's place, 2's place, and our 4's place. So what number do we really have represented here? Anybody can come off of mute.
7.
Exactly, that's the number 7. So I'm gonna write equals 7, and watch me put a little D at the bottom, or actually I'm not gonna put a D, I'm gonna put a 10 down here, which shows that I'm in base 10. So 111 in base 2, or in binary, is really the number 7 in base 10, or decimal. And then the number 10, we know, is already given in decimal. So it's just itself, it's 10 in decimal. Now, if those little subscripts are confusing to you, you definitely don't need to write them, but make sure you know you're comparing this number with this number. So if we're writing them least to greatest, what's the lesser value?
7.
It's going to be the binary 7, and we're going to see it in our answer key, not as 7, but as 111. And then after that comes the decimal value of 10. All right, let's try another one. Number 3. Okay.
I know.
So did you guys want to see specific letters, or shall we just go through them all?
Wait, Miss, can you repeat that?
Do you guys want to see specific ones, or should we just go through all 4, A, B, C, D?
We can go through all of them, or it doesn't really matter.
All right, we'll do the first 2, and then you guys will get the hang of it. So let's do the first one. What should we do in our first step? As always, we're going to copy it down with spaces. And we're going to write their place values. Jessica, can you come up and give me the place values starting on the right, please? Yeah, at the bottom. So we have the 1's place, and then we have the...
And then the 2?
Keep going.
4, 6.
Careful. We're not counting up by 2. We're actually doubling. So it's 4 times 2.
8.
And then 8 times 2. So the next number would be 16, and then 32, and you'll get used to this more and more. Okay, notice that we don't have a 1/28 place, and that's okay. We don't care. There's really a 0 there, but we can ignore it. So let's figure out what this is. What ASCII character? So which of these letters? I'm kind of a bad teacher. I skipped the whole introduction. Sorry, give me a second. Let me read this. So ASCII we learned today is a character encoding scheme that uses 7 bits. By the way, each of these numbers is a bit. Bit means it's a contraction. It's a binary digit. So 0s and 1s are our digits, and since we're in binary, we'll just call them a bit. So notice that in this problem, we have 1, 2, 3, 4, 5, 6, 7 bits, okay, to make up our number. So it's a 7-bit character encoding scheme to represent each character. The decimal values 65 through 90 represent the capital letters A through Z as shown below. You don't need to know this graph, it will be given to you. This is, by the way, another AP question. So letter A says, what is the ASCII character? Which letter is represented by this binary number? And we already started working on it. So let's figure out what number it is. We have a 1 in the 64's place. We can ignore 32, ignore 16. We have an 8, a 4, ignore 2, ignore 1. So adding these together, that gives me 70 what?
76.
70, oh, all total, yes. So these guys give me 72. When I add the 4, I get 76. So your answer is not 76 though. We need to map it to a character. 76 gives me the letter L. And that would be my answer for part A. So in the box here, I'm gonna write L. I write letter A, L. Then I would write letter B, fill that in. Letter C, whatever that is, and letter D. So let's do one more. Why don't we try letter C? I'm gonna give you guys 30 seconds to start it. See if you can get to the end. So we're gonna do letter C. Okay, Miss Ingrid, can you come off and give me the place values, please?
Okay. So wait. Oh, from there? Oh, okay, I was gonna. Never mind.
We're always start on the right side.
So 1, 2, 4, 8, 16, 32, 64.
Beautiful. Can you tell me what we would do next?
Then you just add up 64 plus 16 plus 8.
And 64 plus 16. Carry the 1.
Oh, sorry.
Did you get that? 80? Did you guys get the same answer as me?
Yes.
So what's our final answer here?
X.
And that's it. That's how we would do this problem. Nice. So it looks scary, but it's actually pretty straightforward. There's just one extra step of getting the letter. For part 4, it says paste a photo of your work. So as you guys can see, there really is work to show. And that's what I want to see in part 4. So if you're using scratch paper, that's fine. Just number so I know what work to look at. And then in your reflection, just talk about what you learned. I'm actually going to read these. It helps me be a better teacher. So that's it. That's our whole office hours for today. Any last questions before we go, you guys?
Yes, Miss. For the code.org for lesson 4, it asks how many bits would be needed to count all those students in class today, but I don't know how many students were in class today.
That is so funny. So today I did not ask you guys to do any code.org. It will specifically be listed in your homework if I do want you to use code.org for your homework, but let's just say we had 34 students in class today because it's an interesting question.
34?
How would we answer that? Yeah, let's say, I think there were 34.
I would just do, it would be like, wouldn't it be like 4?
How many bits? So you're saying 4 bits. 1, 2, 3, 4. Can you explain why?
Like 4.5, not exactly 4, because wait, Miss, I think I'm wrong.
Like, so for instance, you can't have a half a bit, right? You can't start writing a 0 and then not finish it.
Yeah.
So how many bits do we need? For instance, if I had 352 students in class, I would need 3 decimal digits because I need a 3 in the hundreds place a 5 in the tens place, and a 2 in the ones place. But if I have 34 students, I only need 2 digits. But in binary, we're using bits, not digits. So what number, first here's the easier question. What number in binary gives us 34? Can you guys do that conversion?
Wait, 34?
Yeah, let's convert it to binary. So remember, we're gonna put a 1 in the place that is the biggest that fits inside. So should I go to 32, yes or no?
Yes.
Should I go to 64, yes or no?
No.
No, because 64 is too big. So we are gonna put a 1 in the 32 place. Where else do we need a 1 to make 34?
At the 2.
In the 2's place, 32 plus 2 is 34, and then all of these will be zeros. So as you can see, how many bits did we need to represent 34 students?
Oh, that's how you do it. Okay. A lot.
4, 5, 6. We needed 6 bits. Does that make sense?
That's what them.
So
Okay.
you
Yeah.
need to know that, yeah, bits just means how many of these zeros and ones do you need? So let me ask you this question. Ready?
Mm-hmm.
See if you got the hang of it. How many bits would we need to represent each student in a class of 30 students?
30 students. It would be.
Yeah. How many bits would we need this time? So what are you guys thinking?
16. 8.
16.
Yeah. No, wait. No, I'm
Wait.
doing like the.
You're doing the
doing-
work, right?
Yeah. I didn't mean like 16 bits.
Yeah, I was like, oh my God, this is insane. But I understand what you're saying. 16's place is definitely, we need a 16's place. Do we need a 32 place?
No.
Too big. We don't need a 32's place. But we will need 16 and everything below that.
Mm-hmm.
So let's do it. Let's represent the number 30. So a 16 here. How much further should we go?
Oops. Well, I would put 1 at 8.
A 1 in the 8's place. Good. Now subtracting, we're left with 6.
6.
So a
So
1 in
1, 4, and then 1 at the 2. And then, yeah.
and the 2.
And they'll be
And then-
0.
And then we zero out and we are done. So a 0 in the last place. So to represent 30 students, we did not need this 32 bit right here. So I only needed 1, 2, 3, 4, 5 bits this time.
There's nothing to find that. Don't you basically only need to know like one number and then you just count from beyond?
You mean to go from decimal to binary?
Yeah.
Yeah, you need to figure out what's the biggest number that fits inside. That's where you put the 1, and then everything else just flows from there. Gets easier and easier.
So you wouldn't have to actually do the math. You could just like count from 16.
Like 16.
Yeah.
Well, if it was a harder problem, you may actually have to do the math. Like, let me show you really quickly a harder problem. Like, what if the question was 93? I need a 64's place. 128 is too big. Right? But I can't just do this in my head, honestly. I need to show the math here. And I need to actually do the subtraction. 29, so I'm going to put a 1 in the 16's place. 13, so I'm going to put a 1 in the 8's place. And like once you get to a number, like 5, okay, now you can obviously do it without writing everything out. I know 5 is made up of a 4 and a 1, right? But you will need to use math to get started.
Yeah, but I'm saying like here, since we figured it out that you don't need 128 and you can just go on beyond, you'll still have to like, that's still the number of bits you'll need.
Oh, I see what you're saying. I see what you're saying. Is that Ingrid? Ingrid, you're a genius. Yes, I don't know why I didn't even say that. So what
like
you're saying is, yeah,
finish.
can I try and summarize it, what you're saying?
Yeah.
Tell me if I get it right. Basically, you're saying, since I know that I need a 1 in the 64's place, I don't need to figure out all the other numbers because the question, yeah, go ahead.
Yeah, because like the question is how many bits, and then since you already know that you're gonna have to like plug in zeros and ones for the rest of them, you'll just have your answer already.
Beautiful. Couldn't have said it better myself. Exactly. So if the question says convert it to binary, then yes, do the math. But if the question says how many bits, you don't need to do the math. You just need to figure out the biggest number that fits and then figure out how many bits fall after that. So this one would be 7.
Yeah.
That was really awesome. I'm so glad we stayed and figured that out. I'm going to post this to the class piazza